Hello everyone. So in the last video, we completed till the Lothar-Meyer's classification. Now we have to start the Mendeleev's periodic table. In the last four periodic classifications, it was not close to the modern periodic table, but the Mendeleev gave a periodic table which is very much near to modern periodic table. Okay. Periodic table. Mendeleev's law for the periodic table is the physical and chemical properties of elements are the periodic function of their atomic weight. In Lothar-Meyer's classification, he said that physical properties of elements are the periodic function of their atomic weight. But Mendeleev explained that chemical properties also the periodic function of atomic weight. The physical and chemical properties of element are of elements are the periodic function of their atomic weight. He explained the characteristics of periodic table. At that time, only 63 elements were known. So, with the help of 63 elements only, he explained the periodic table. Because the noble gases, they do not react easily to any element, or they do not react with very easily. So, only 63 elements were known, and many heavy elements also were not known at that time. So he made a periodic table with the help of 63 elements. So a characteristic, we will write in the characteristics of periodic table. Periodic table. This is the characteristics for the periodic table of Mendeleev's periodic table. First point in this, 63 elements were known. And noble gases were not discovered. Noble gases were not discovered. And he was the first scientist to classify elements in horizontal rows and vertical columns. These are the characteristics of Mendeleev's periodic table. First scientist to classify the elements in horizontal rows and vertical columns. Third point, horizontal rows are called periods. Rows are called periods and vertical rows are called group. Vertical columns are called group. Vertical columns are called groups. Okay, so now as we know the characteristics of the periodic table of Mendeleev, he arranged all the elements in periodic table in order of atomic weight. In characteristic also we know now. Now the merits and advantages. Merits and advantages. First, Mendeleev predicted about the properties of some elements which were not known at that time. So Mendeleev helped to discover some elements like germanium, gallium, scandium. At that time, these elements were not known. Only 63 elements were known. So some elements like germanium, gallium, scandium, these elements were not known. So in merit and advantages, we'll write Mendeleev had predicted about the properties of some elements which were not known at that time. So what he wrote for the name of those elements like germanium, Ica, silicon for germanium, Ica, aluminium for gallium. So with the help of Mendeleev's periodic table, we got to know the properties before the discovery of germanium, gallium and scandium. And Mendeleev corrected the atomic weight of some elements which were wrongly calculated before. So this is the first merit. Second merits and advantage. Mendeleev corrected atomic weight of some elements which were wrongly calculated before. Uranium, beryllium, indium, gold, platinum, these elements atomic weight were not known correctly at that time. So Mendeleev's periodic table helped to discover the atomic weight for these elements. Now we will talk about the failures of Mendeleev's periodic table. Failures of Mendeleev's periodic table. No separate place were given to the isotopes. So it failed here. No separate place were given to isotopes. So isotopes are same atomic number but different mass number. Different mass number, like 1H1, 1H2, 1H3. These are isotopes, and the atomic weight of each atom is different, but this all are same element, hydrogen only. Hydrogen's isotopes, hydrogen, deuterium, tritium, they have different atomic weight, but he did not give the different place to each atom. So it failed here, and then some elements with the higher atomic mass were kept before lower atomic mass, which contradicts the Mendeleev's rule. This is the second point. This is first. Some elements with higher atomic mass were kept before lower atomic mass. Lower atomic mass, which contradicts the Mendeleev's rule. For example, cobalt and nickel, 58.93, 58.73. The atomic weight of nickel is lesser than cobalt, but still Mendeleev kept it after the cobalt. So it is contradicting the Mendeleev's rule. Tellurium and iodine. Atomic weight of tellurium is 127.6, and for iodine 126.9, but still he kept iodine after tellurium. So it was contradicting its own rule. So here, after the merits and failures, Mendeleev's periodic table complete here. Now the modern periodic table. Which scientist gave the modern periodic table? Mosley. Mosley was the scientist who bombarded dense X-rays, the dense X-rays on elements, and he gave that the periodic properties of elements are based on atomic number, not the atomic mass. Mosley work on X-ray and explained modern periodic table is based on atomic number. Now, the modern periodic table we already will see for the finding of atomic group, elements group, period, block, that we will study in the whole chemistry. So now we'll see the definitions in periodic table. Some definitions like diagonal relationship, transition metals, definitions in periodic table. Diagonal relationship first. Second, transition metals. These both definition we will see. So for the diagonal relationship, some elements of second period matches properties with the third period's element. Some elements of second period matches properties with third period's element. Second period's elements are lithium, beryllium, boron, and third period's element sodium, magnesium, aluminium, silicon. So the second period's property will diagonally matches with third period's element. So lithium has same property, some property same as magnesium. Beryllium has some property same as aluminium. So this is called the diagonal relationship. Diagonal relationship occurs because of, here it is same, charge versus size ratio, or you can say because of same ionic potential. Ionic potential. What is ionic potential? Charge of ion divided by size of ion. This is called ionic potential, and it is same for the lithium versus magnesium, beryllium versus aluminium. So it is same. That's why it is keep having the same property in diagonally. Now transition metals. Transition metals, all d block elements which have at least one unpaired electron, either in neutral state or in their common oxidation state, is called the transition elements. Here we should understand that neutral or in ionic, okay, in any form. I'll write it first. All d block elements which have at least one unpaired electron, either in neutral state or in either in neutral state or in their common oxidation state. Is called transition elements. Group 3 to transition elements are from group 3 to group 12, and zinc, cadmium, mercury are not the transition elements. Because they do not have any unpaired electron, either in neutral or common oxidation state. For example, zinc. If you take zinc, zinc has 30 electrons in. So in the last, it is electronic configuration is 3d10 4s2. So there is no unpaired electron. So it is not transition element. Then cadmium. In the cadmium electronic configuration 4d10 5s2. So there, here also no unpaired electron is there. For mercury also it is like this. But for copper, if you see in a common oxidation state or in neutral state, there will be at least one unpaired electron. So copper is a transition element. For scandium also, for every element of the D block except zinc, cadmium, mercury. So copper, for transition elements, examples, there are lots of examples, so there's no need to write it. The next topic, finding block, group and period. This we will do in the next video. Thank you.